Welcome to the lesson for 8.5. This is geometry, this is similarity stuff, and today we are learning about side, 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 and side, angle, side, and how it relates to similarity instead of congruence. We've learned about these congruence postulates and theorems before, and now we're learning about how they apply to similarity. So make sure you use those extra examples in your book, and let's get into the lesson at this point. Here we go. So, first of all, side, 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 similarity theorem. I'm going to draw some pictures off to the side too, so we'll put that in our column off to the side, or the margin. But SSS, similarity theorem. Let's start with that. And this is theorem 8.2. We'll put that number down as well. This is what the theorem says, and it's totally like, very similar to, okay, very similar to side, side, side congruence postulate. I think it was a postulate, that one, postulator theorem. I can't remember if this book called it a postulate or a theorem off the top of my head, but in two triangles. So we're having two triangles. If this is true, if you have three corresponding sides that are proportional, notice not congruent but proportional, if this is true, that implies, we can draw implies like that. We can use the single arrow or the double lined arrow like that, either way. That implies we have similar triangles. And so let's draw a picture off to the side over here, and we'll denote some things in the different colors. So I'll draw a picture of a triangle. I'll pause it just a second and bring it right back. Okay, so I'm going to copy this triangle that I just drew. I'm going to make a duplicate of it. These would be congruent triangles since they're duplicates of each other. But I want to scale this one down a little bit. So now it's become similar. It's become a similar triangle. It's still proportional the way this program works, or the way this little function right here in the corner works. It just scales it up or down, just kind of shrinks it or makes it bigger. So I'm going to make mine kind of like that. And then from there, we are not going to put, take out a different color at this point, but we're not going to put congruent markings on it. I'm just going to designate it like this. So I'm going to say that this one, I'll just put numbers instead. So this one matches up with this one right here. Maybe I don't want to do that either, because then you might think they're congruent. Why don't I do it like this instead? So 1x, I still don't want to do that either. Let me think of a good way to do this. So I don't imagine that most of you will have like 4 different colors. If you did, that might be a good idea, or 3 different colors. But let's just put, for those of us that just have the one color, we'll put a dot there and a dot there. Those two things match up. I didn't put a tick mark here and here, and this is not an official marking you're going to see in your book. A dot next to that and a dot next to that means they're similar or proportional. But for the sake of argument right here, for the sake of hopefully making it clear, I'm saying these two sides match up, these two sides match up with the two dots. Again, not an official marking, but just saying that these things match up. And then the 3 dotted sides match up. These are all proportional to each other. So 3 dots to 3 dots, 2 to 2, 1 to 1. And for the other one, for side, angle, side similarity, just like before, we're talking about two sides and an angle. That's what the S and the A stand for there. Side, angle, side similarity theorem. This is 8.3. And again, you got two triangles. So in two triangles, this one says this. You have two corresponding proportional sides, and the included angle is congruent. So included angle has to be the included angle. It can't just be any old angle. Remember, if you had something like ASS that didn't work for congruency, that also doesn't work for similarity. So think about how it's spelled, think about what it spells, and then if you say it out loud, you're like, oh wait, I'm not supposed to say that in class. It's going to hold for similarity as well. So if this is true, that implies you have similar triangles as well. So I'll draw some pictures. Again, over here, I'll draw a triangle. I'll make this one look a little different, just so you don't think all triangles are the same here. We'll say something like that, and I'll make a duplicate of that, but I will shrink it down. Alright, if you had something like that going on, we could, let's put our different color markings here, and let's say this one is matching up with this one. These two are proportional, meaning that, so again, not an official mark. Don't put this on your classwork or homework later saying, oh, this is what you told us to do, Mr. Wagner. No, I'm just trying to explain it right now. So let's say that is the case, and then you have this included angle in between this side here, and this side here. So these two, the one dots, they match up, they're proportional. The two dots match up, they're proportional. And then the included angle, if it was the non-included angle like this one and this one, you would have angle side side, or ASS. Warning lights going on. Don't do that. Don't say that. I don't want to hear it in class. You shouldn't write it down on your paper. That's your big hint as to remember that doesn't work. Okay, so these two work. Could there be some more? We learned about angle similarity already. There may be some more as well, but we'll check that out later in this lesson and future lessons. So let's get into some examples here. I'm going to draw another triangle. Just listen for a few seconds here. I'm going to get 3 triangles drawn. I'm going to rotate them a little bit, and then I'll have you draw them from there. So I'll draw one like this. Okay, I'm going to make some duplicates of that. And then I'm gonna shrink and rotate some stuff. So still just watching, but I want you to see that I started out with the same triangle. I'm gonna spin this around. I'm gonna shrink this down. And so because I shrunk it down using that special tool where it just keeps everything proportional, these are going to be similar, at least the way I drew them, but we're not going to trust the looks of the picture. I am purposely drawing these to make them look like they're similar. Why are you doing that, Mr. Wagner? Because that's what the book's going to do. That's what you're going to see on your test. They're going to look similar. You have to determine whether they have to be based on the information in the pictures. And so there's a big one. Let's rotate that a little bit. We'll go like that. Go up here a little bit more. Okay, so let's draw, at this point, draw the pictures on your paper. So something like that. The question to you, are these, or which are similar? Which of these are similar? Which are similar? So this one we're going to label with K, L, and M. This one I'm going to go with O here, P here, and N here. This is 18, this is 15, this is 6, this is 3, 5, and 7. And then let's go with Q, S, and R. This is 25, 30, and 10. Okay, so which are similar? We have to check and see what's proportional. So do we have corresponding sides that are proportional? How many pairs, or how many sets? 3 sets, 3 pairs of corresponding proportional sides. Do they have to be congruent? No, that's not what similar means. They have to be congruent if the triangles are going to be congruent, but they have to be proportional if the triangles are going to be similar. So let's check out the ratios. Let's check out one triangle versus another triangle. We can only check 2 at a time here. So let's check the ratios for triangle KLM and triangle, so KLM, that would be the longest side, and then the middle side, and then the shortest side. If I compare that to this one, longest would be NO, so I would put NO first, and then the middle side would be OP, so I would put P next, and then to end there. So let's check these ratios and see what we get. So compare longest to longest. Compare longest side here to longest side here. That would be Km. I'm actually comparing shortest. Let's compare shortest to shortest. So Km to NP. You could compare longest to longest first if you wanted to. You could compare middle to middle first if you wanted to, but I'm just going to keep it consistent with what I had before. So this would be 6 over 3, which would be 2, which would equal 2, or you could say 2 over 1. Technically, being a ratio, I think I should put it over 1, but think of it as 2. If these other ones equal 2, then you're going to be good to go. Alright, so LM, this is going to be the middle length, the middle measurement, 15. The middle one here is OP. You can both look at the pictures and tell, and you can compare this one to this one. They're supposed to match up if you did this statement right, if you did the work up there right. So this would be 15 over 5, which equals, I'm sorry, 3 over 1. So this, let's circle that, let's circle this. These are not the same. I'm going to just, for the sake of practicing, do the last one too. So KL over NO. What is that? KL is 18 over NO is 7. That you can't reduce. It would be 2 4/7. And so that, sorry, you look at that, that, and that. Let's put that in a different color. Let's circle these things in a different color instead. So let's circle that, and circle that. These are, write this off to the side, not, you can abbreviate proportional like that, and so these are not proportional sides. So are these two similar to each other, KLM and NOP? They look like they might be, but based on the numbers, based on the information there, no, it's not going to work out. How about the ratios for, we got to check, or we're going to check another pair. So let's check this one, this medium-sized triangle to this big triangle, the biggest one over here. So KLM again. Let's compare that to KLM. We had biggest to middle to short side. If we go in that order, K to L to M, so we keep it in that order. Q to R to S would keep it in that big to middle to small one order. Q, R, S. So let's check it out. KM over, that's first and third letter here, QS. You can verify that matches up in the picture as well. That would be small side here to small side over here. So this would equal 6 over 10. So as long as we're comparing the same things, I could actually compare QS to KM as long as I compared these sides first to these sides second. But I'm going to compare these sides first to these sides second. Keep that consistent all the way through. This equals 3 over 5 reduced. So let's see what else we got. We've got LM. That's the middle one over the middle one here, SR or RS. That is 15 over 25. Can we reduce that? Yeah, we can. So divide by 5. We've got 3 over 5. Hey, we got 2. We're close. One more will do it for us if it also equals 3 over 5. So let's check the last one, KL over, that would be over QR. The longest one compared to the longest one in each triangle. That's 18 over 30. If you divide by 6, that's 3. And that is 5. Thank you very much. We have proportional sides. All 3 are proportional, therefore I'm losing my voice. And the sides are all proportional. So proportional sides, let's write that down. Proportional sides, different color here. Proportional sides. So by theorem, we go back to this theorem. We could say theorem 8.2, but I think side, side, side is a better way to say that. So by side, 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 you can use this for similarity. So by side, side, side similarity theorem, or even just SSS in that symbol, that would be fine with me too. You can say that triangle KLM is similar to triangle QRS. And then how about the other pair. We have actually 3 different sets we could put together. So we tried this one versus this one. That didn't work. This one and this one are similar. If this one was going to be similar to this one, we haven't checked that directly, but indirectly we should know that based on the fact that these two are similar and this one was not similar to this one is also not going to be similar to this one. They would all have to be similar to each other or not at all. And so we could say that I shouldn't say not at all. These two are similar to each other, but this one would have to be similar to this one if it's also going to be similar to this one, since these two are similar. Wrap your head around that. I hope you can. So rewind, pause, rewind if you need to think that through. We're going to write it down here though. Since triangle KLM, this is what I was saying in a relatively concise way. So it isn't similar to triangle NOP, and triangle KLM is similar to, which we can put like that, is similar to triangle QRS. It follows that triangle NOP isn't similar to triangle QRS. So the only pair that worked was this pair right here. KLM was similar to QRS. Notice not congruent, but we have the symbol for similar instead. Let's check out a second example. Example 2, are these similar? This one I'm just going to give you 2 triangles instead of 3. This one will be a little more straightforward, I would say. And here's one triangle. Say we have a triangle that looks like that. And I'm going to duplicate this now. I'm going to make exact copy, and I'm going to scale it down like that again. And I'll rotate it around. So does it look like it's going to be similar? Yes, that's on purpose. But let's see if it actually is. This one I'm actually going to reflect in the y-axis as well. Where are we at there? Flipping the y-axis. There we go. So I flipped it around too. But I just transformed these objects. I kept the scale the same as I was doing that. But now let's put in some numbers. And let's see, based on the numbers, if this has to be true. So let's say I start with this 9, that angle, and a 6, a 3 right here, that angle, and a 2. So are these similar? Do you have proportional sides first of all? 9 over 6 or 9 over 3. Let's compare this one to this one. So 9 over 3, that equals 3, or 3 over 1. And we have 6 over 2, this one to this one, would also equal 3, or 3 over 1. These are the same, so the sides are proportional. Let's put our different color here, circle that, and we can say the sides are proportional. And then do we have an included angle here? Yes, we have the angle in between them. It's not the one outside of there, it's the one that where these two sides come together, where the 3 and the 2 comes together, it's the angle in between them. Where the 9 and the 6 come together, it's the angle in between them. And so we can use now side angle side similarity and say that these two have to be congruent. So that's an example of SAS similarity because of that. So the sides are proportional, and we can also say included angles are congruent, and so therefore by side angle side similarity theorem, that's theorem 8.3, you can use that too, but this is better, it's a better way to name it, they are similar. I told you that one would be a little easier, more straightforward. We only had 2 to compare instead of 3 triangles. And so now let's apply this to a real life problem. Interesting problem. I love to hike. You don't know that about me. Now you do. Love to hike. And sometimes I come across rivers when I'm hiking. Sometimes they're raging torrents, and I'm a little scared, and I I'm worried that I might get swept down the river. It would be nice to know exactly how far it is that I've got to walk across this thing to get to from one side to the other if this is a raging torrent. So on here, I'll use black for now, that's fine. So let's say I'm standing right here. You can just listen for a moment. So let's say I'm standing right here and I want to go straight across here, but I don't know how wide it is. I've got this ballpark estimate. I can just look at it and say I think it's about this, but I want to be exactly sure. Maybe I've even been thinking about trying to build some sort of bridge or get some sort of log to put across here to make it safer to go across. So let's see what I could do. Let's see what I, as a geometry teacher, would know to do. Since I know about similar triangles, and since I know that I can use them to help me figure out missing parts of triangles, this is what I would do if I were in this situation. I would walk from here out to here, and I would mark that off with my pace. I know what my pace is. One big stride, like the football referees, that's about a yard. And so I did like 1 2/3 paces, 5 feet. So I went out 5 feet. I'm pretty accurate with that there. So I'm going to say that's 5 feet. And then from there I made a 90-degree turn and walked parallel towards the river, and I walked 2 2/3 paces, or 8 feet. I walked 8 feet that way. And so this ended up being a right angle. I made sure that I made a 90-degree turn right there, parallel to the river, and that was 8 feet right there. And then from that point, I had looked straight across the river, right over here. That's what I'm trying to figure out. What is the distance from here to here? So I don't know that yet. But I looked from there straight across, got that perfectly straight, and then I looked from here, and I had a little stone. I put a little stone right there, so right where I was here, I looked to that stone, and then I looked across the river going in this diagonal kind of direction here, and I found a little landmark over here. I looked over there and I saw another little stone, so I'm like, oh, there's my spot right there. Okay, and from there I see that I have another right triangle right here. So here's my other right triangle. And could you walk off the distance from here down to here, look straight across and see how long that was? Yeah, I say that would be pretty easy to do. So this would be 42 feet. I'm saying that's what I walked it off at. So I walked from here, pasted out to there, 42 feet I approximated that at. And so from here, I could call this X. This is what I'm going to try to figure out. And so what do I know about this angle right here and this angle right here? Let's put a different color with that. I know that this angle and this angle would have to be vertical angles are congruent. Beautiful. Vertical angles right here. These two have to be congruent to each other right here and right here. So put that in a different color. Draw your nice river right here. And we've got this going on right here. So if I have this triangle with two angles matching up with this triangle with two angles, I can say for sure that this has to be similar to this. That's going back a couple lessons, but that's the angle-angle similarity postulate. So we can say this by angle-angle similarity. We can say the two triangles are similar. And because they're similar, that's going to mean the sides are proportional. So because they are similar, sides are proportional. So if you can prove the sides are proportional, then you can prove they're similar. But if you can prove they're similar, you can also prove that the sides are proportional. So you can say, therefore, you can set up an equation here. I could say that, well, this is going to be the the longer side matching up with the longer side is going to equal this shorter side, the river x part, over this shorter side, the 5 part. So I could say that 42 over 8 would equal x over 5. As long as you're comparing the same sort of things to each other and you keep that going straight across, you're going to have an okay proportion. So like I could have actually said 42 over x equals 8 over 5. I would be comparing long to shorter part and then longer to shorter part there. But this is the way I chose to do that. And at this point, different color, cross multiply. Show me that with a different color. And then let's do that. So 42 times 5 is going to equal 8 times x, or 8x. 42 times 5 ends up being 210. And there you can divide by 8. That'll cancel out there. And there you're going to get x equals 210 over 8. Now, you're not going to tell somebody that, oh, this river is 210 over 8 feet wide. That wouldn't really make sense to say that. You can reduce this. You can divide by 2. This would be 105 over 4. Still, I don't think that's going to make much sense to somebody, though. How many whole times does 4 go into 105? If you try that out, you're going to find it goes in 26 whole times. And you'll have 1 left over. 4 goes into 125 times, so you have an extra 4 plus 1 extra 1. So you could say it like that, 26 1/4 feet, or you could say 26.25 feet, or you could even say 26 feet, 1 little tick mark meaning feet, and 3 inches. 0.25 feet, 12 inches in a foot would be 3 inches. So different ways to say the same thing. Therefore, if you're thinking of, with a backpack on, trying to like run and jump over this river, not the best idea unless you are the world's best long jumper. With a backpack on, good luck with that. The world's top long jumpers, male long jumpers can, I think the Olympics, the guy that just won it in this past Olympics was like 27 feet. I know the world record's 29 feet something inches. You might want to go get a log or something like that and put that across there if this is not safe to traverse. You'll definitely want to have some walking sticks or poles to make sure you don't get swept downstream. Okay, that'll do it for this lesson. And let me know in class if you had any questions. Go back and rewind as needed.